Welcome back to the stream. So yesterday we've got some of our sprites working, so now we've got grass, and we've got sand, and we've got what else we got? Let's check it out. So if we take a look in our play state here, see how we're drawing tall grass? We can instead just draw grass. And what our grass is just green like that. So the idea for today is to change it so that twofold, instead of us only drawing the same sprite for every single frame, we're going to try to set us up with a way to draw whatever frame we want. So we're not limited to just drawing, you know, a whole page of grass or whatever. So let me just check, make sure we're still streaming here. It's looking a little laggy on my end, but we'll continue. So I think the idea is, and there's one more other thing I wanted to change, is if we really just cosmetic, because when I play the game like this, you'll see that we cut off our little character in the background there. That you know, this guy right here on screen. So we can actually move the window so that it doesn't do that. So let's go to our play state here. We'll go to after all of our updates, and we'll say love.window.setPosition, and I believe we can give it an X and Y here, and it'll move to the left a bit. Yeah, it did. So see, if we give it 0 here on the X, then it loads straight to the left there. So we just want, I just want to see the beautiful artwork for the guy, Sekijo, chugging some monkey boost down there. So I just scooted over to the left a bit. It might make it a little more aligned. When you look at the, yo, Saltamanga, check it out. We got the background up. So Sam is the artist of the beautiful artwork here. Check that out. Let me move the mouse. So look how gorgeous that is. So he hooked us up with some custom channel art, right? It looks so good. I can't be more happy with that. So that's going to be the background of the streams for the foreseeable future. But let's get started here. So Sam, I literally just showed them, instead of rendering the game, he was kind of covering Sekijo, so I just scooted it over so you didn't cut off his arm with the monkey boost. So I just scooted it to the left a bit, so we didn't cut that off. But anyways, let's get going here. So we're gonna be drawing all these different frames, all these different sprites to the screen. Now, right now we've got it set up where we have, let's see where we've got grass. Maybe in our play state here. Really? It's in our main then. Yeah. So we've got these drawables. So the whole idea here is, instead of just one 16 by 16 image, we want a whole sprite sheet. So we need a way to kind of chop up into that sprite sheet and be able to draw appropriate pictures. Even though it's one sprite sheet, we're going to say, you know, index 1 is dirt, index 2 is sand, index 3 is bottom edge grass, that sort of deal. So we can just pull in one sprite sheet, tell it explicitly what to draw where, so we can draw our map out, and then that'll just be so much better than trying to draw individual drawables like this. So we're going to work on that. Now, I took a couple courses of CS50 game dev, which really helped me out and get started. Now let's give us a file here called util.lua. That's what Colton Ogden does, so that you can write some custom functions in here. And we want to do this this function GenerateQuads. Okay, for now we don't have exactly what it is, but before we get too far into that, we want to make sure that our main dependencies knows about it. So we don't have a dependencies class yet. Normally I put all of this stuff in a dependency file. Let's just go ahead and do that now. So we can, in our dependencies, we'll make a file called dependencies.lua. And this is just a way to kind of clean up all that gunk. So we can go take all that stuff from our main here, all this stuff, we can go ahead and put this in our dependencies. So it's kind of out of the way. Here we go. So we're going to put all this here, and then we want to require that util.lua that we just made. So that's going to have some useful functions that we need access to. And it's what, in the main? Is it in the main folder there? Util.lua. Okay. I think it's there. Yeah, I agree, Saltamanga. Very cool background. Very cool. Thank you very much. It's super sick. I absolutely love it. Okay. So, I guess let's just double check our util was in our source, not just randomly in there. So let's go ahead and require it from our source folder. Okay, and then we'll just run the game to see if it crashes, and it does. So we don't have, what we have to do in our main is require our dependencies, which is what we did not do. So we'll just require our dependencies here, and then we should be able to use that. And it's what, source dependencies? I think, let's see. No, it's just dependencies. Dependencies folder, and then dependencies the file. So we'll go back, and it should be dependencies folder and then dependencies, which is a little redundant. So maybe we just do /dependencies, and we'll put dependencies.lua in the main repo here. So there's I know there's an easy way to move files, but I'm not about to figure that out right now. So what we'll do is we'll just remake it. Right here we go %sign dependencies.lua, and then paste it. Okay, and then we can go ahead and delete our dependencies class, or whatever you want to call this. Okay, let's see if we run. Okay, we're breaking everything today. Source.util.lua not found. So source util.lua, we've got it. It is in there. Did we capitalize it? No. Oh, Lua is kind of smart. You don't need to put a .lua. You just put there, even though it is a .lua. So we're back in action. So we've got our little guy. We've got now our dependencies out of our out of our main function here, which cleans it up a lot. And then let's go ahead and get writing to that that new function here that's going to help us out draw all the tiles. So in our dependencies folder, we've got that. Actually, no, where is it? You know what? We messed up here. We shouldn't have put util.lua here. I'm going to put it in our dependencies because that's where it should be. And then we'll have to redo the one line of code we did for that. So util.lua. And for now, it's going to be just a function called GenerateQuads. And then we need to make sure our dependencies file is referencing the correct well, let's see, we put this new one, util, in our dependencies folder, so we need to make sure dependencies know that util is in our dependencies. And we should probably move basically all of this stuff into dependencies like these ones are. I won't bore you guys with that, but if we're running, we can go ahead and start to get going here. Okay, so Colton Ogden, who runs the CS50 game dev channel or class, whatever you want to call it, he wrote this function called GenerateQuads that we're going to use. So I've got my little cheat sheet in front of me here to help us. I can talk through it so you guys can follow along with what I'm doing. But let's go here to our util and we'll add it. So first of all, this GenerateQuads function takes in a couple arguments. First one is the atlas, of which you want to generate quads for, the tile width for how wide each tile is, and then the tile height for how tall each tile is, okay? Then we need a couple variables. We're going to keep track of the sheet width, which is going to be like the individual quads. So we need to tell it how to split up how wide it is. So if we run this getWidth function on our atlas, it'll get the width, the whole width of the atlas, but we want to divide that by the tile width to give us the sheet width. And then same thing with height. So we want a sheet height. And we're going to run the getHeight function on our atlas. And then we're going to divide by the tile height to get the sheet height. Okay. Then we're going to start counting at 1. So this ultimately, this sheet counter is ultimately going to be, I guess it's like, this function is going to return a sprite sheet. And the sprite sheet is just going to be how the sprite sheet's cut up. So the sheet counter is just the way to index into the sprite sheet for each quad. So we need a value for each index so that we can save the quad in there. So that's what sheet counter gets 1 is doing, and Lua is 1 index, so we're keeping it there. Then we're going to have an actual sprite sheet, which is a table full of our quads, essentially. So we're going to assign it to be an empty table first. And then we do a nested for loop, but we start with y because if you think about the nested for loop, for every row, we want to do a column number amount of things. So that's why we start with index y, because y is up and down and x is left and right. So we start with y on the nested for loop here, and we're going to go sheet height -1. So this is literally just, I'm going to do this a sheet height amount of times. And then here's the inside of that for loop, which is a sheet width minus 1. So for every sheet height, we're going to do a sheet width amount of things. That's all this is saying. And what we're going to do is this is where we're going to assign each quad. So we need to index into our sprite sheet table at the number of the sheet counter. And what we're going to do there, this is a table. Everything in Lua is tables. So at this index of our sprite sheet table, we're actually going to assign our new quad. So the function for generating quads is love.graphics.newQuad. And it takes in a couple arguments. So it takes in an x, a y, a width, a height, and then the dimensions of the entire atlas. And yeah, Salto Manga, I agree. Payoff for the art was super worth it. I mean, I only waited, what, 4 days? 3 days? 3.5 days, and you pumped this out for me? That was really cool. Everyone who's on stream, go give Salto Manga a follow because he's a super talented artist and he made the wonderful artwork you're looking at behind the screen here. So he's got an Instagram and Twitch, so go give him a follow for sure. So we're gonna take those arguments we take from the parameters of our function itself, and we're gonna say that the x is actually an x times the tile width. Yeah, Sam, you're super welcome, dude. It's rad art. I love it. And then we're going to do our y times our tile height. So this is just since our x and y, you know, we're going to start. And this is why we initialize these at 0. We initialize these at 0 because 0 times the tile width gets a 0, and that'll be the top left quadrant of our quad. So that being 0 on the first pass is actually accurate. So then we need a width and a height, so we give ourselves the tile width, and then the tile height, and then this is we need to do this by tile height. That's the argument, and then width and height. And then we got the last argument, which is the dimensions of the original atlas. So we're gonna run this get dimensions, and I spelled that wrong. Get dimensions function on our atlas, and that's going to be the last argument for our new quad. Now, we don't have to put this on a new line. We could do it over here. And then we're going to take our sheet counter and we're going to increment it so that we don't overwrite the index of the table we just wrote to. So we're going to go ahead and increment that sheet counter. And then once all that's done, for all the sheet widths and sheet heights, all we do is return our sprite sheet table. So at the end of the day, this GenerateQuad's function, when we give it these 3 arguments, is going to spit out a table. And as far as this function is called, that table's called sprite sheet. And all that sprite sheet is a list of indices that have the quads, and all a quad is just a section of an atlas. So we give it how wide to make each quad, we give it how tall to make each quad, and then this goes through and dices it up so that we can index things at the exact tile width. So this, instead of just rendering one 16 by 16 sprite and we're rendering that thing for the whole screen, we're able to give a whole atlas of sprites, and we're going to say, okay, sprite sheet at index 1 is grass, sprite sheet index 2 is water, and then we're able to just have one picture really, and we're able to reference and draw different things from one picture. So it's just a really fancy way to do ultimately a lot of pictures, because we're going to have a bunch of sprites to draw. And I'm assuming back, you know, for Game Boy games and stuff, they had to do stuff like this to be more, you know, memory aware, memory safe, I guess. So we've got this generate quads in our util. So now we'll have access to this function in our other states here. So the next thing we want to do is give us a way to identify what quads we want. So another thing is, let's make ourselves a little tester, a sprite, real quick, so I can demonstrate how this is going to work. We'll just, oh god, here we go. Okay, yep, I get it. Okay, so we just want, let's do a 48 by 48. So that should be 3 by 3. So we'll just give ourselves a 16 pixel circle for now, because we're just trying to just show off what this is actually doing, and 16 size. So we're gonna make this is one PNG, right? So we're gonna be feeding this into our GenerateQuad function so that I can show you guys what exactly this is going to be doing for us. So I'm just trying to get unique colors here so that we can see what it's going to do ultimately. So try not to take too much time. Okay. And then what we can do is give ourselves a little number too, just so we can kind of see. And I'm doing this with my left hand on a right-handed mouse because my desk doesn't have room for my right hand with the current setup. Oh lordy. It's okay. It's okay. All right. That's a 7. Ask anybody. Okay. Oh god. Okay, in the 9. Okay, so we'll see this. Oh, shh, that's not a 9, huh? Can you set a color map equally spaced on the number of colors you want? You could do something like that. So every time you render something in Love, it needs a color to be set as like the behind color almost. So we could just draw like a white square and set that behind color to be a different, what you say is color map, I guess. So we could do something like that, but I'm just trying to illustrate how we're gonna slice up these quads here. So let's export this as a PNG. We'll make sure we're in the right folder here, source pics, and we'll just call this 9 circles for now. I mean, we're not going to use this. I'm just using this to make sure our slicing is working for our GenerateQuad function that we just wrote. So we should have access to the GenerateQuad function, and I'm going to harpoon it here so that I have access to it. So this util.lua, I just harpooned it, so we've got it here if we ever need to jump to it. And what we're going to do is here in our play state, not our player class, in our play state, we're going to go up. Now we need a couple of variables as a sort of I guess we can call it like, let's just call it first. First gets 1, second gets 2. So like I can show you guys that we're going to be pairing. We need a number because the sprite sheet is indexed via a number, an integer. But we want to save that int into a variable so that we can call it, eventually call it like, hey, draw a thing full of grass. Hey, draw a thing full of bottom edge grass, because we don't want to have to necessarily remember, you know, that sprite index number 32 is our bottom right grass corner. We just ultimately want to be able to say, draw bottom right grass corner, whatever we come up for that. So let's just give us these, bear with me here, and then we'll do, we'll see if our GenerateQuad's function's working. So we've got these integers saved as variables, and we also, I don't think we have a tile size. And the thing is, we can actually save these in our constants. So we can hop over here, and we don't have a tile size, do we? But we'll go ahead and paste these. Not that. Okay, how do I do this? Okay. That's not what I wanted. We'll need a tile size constant as well, so we'll just put tile size here as 16. So we can reference these in any function. Because by default, actually, every variable in Lua is global unless you otherwise specify as local, but constant notation is typically all caps, which is why I've got that stuff there. So we've got our constants set. So now we've got a couple of things left. We've got to initialize the tables for our tiles, and then we got to render those tiles, right? So we got to do, this is the part I really need my notes for. I mean, I get what we're doing. It's just that I don't want to mess it up and then be digging around for a whole episode. So here we've got, we want to make sure we're in, I guess this would be, yeah, in our .load function, so in our init. So let's give ourselves a table to place our tiles. So tiles is going to be what's holding every single tile that we're going to draw. So if we look at our, where do we do it? Here in our player. Oh, I think it's in our, I'm trying to find the resolution, the rows and columns that we're trying to render the sprites to, which should be at the bottom of this. Okay, it's 8 and 10. So it's 8 across and 10, oh no, it's 10 across and 8 down. So if we remember that, 10 across and 8 down, let's try to remember that. It should be easy enough. We go back to our init function here, and we're gonna say, here's where we're gonna put the actual atlas, right? So we're gonna call this tile sheet, and the tile sheet we made was called 9 circles, right? So we'll pass in the path to the image, which is in source pics, and the name was 9 circles. I think I did it camel case like that. And we do have to put it in a PNG. Lua only recognizes the .lua. So we got to put in the .png there. I'm curious if we just, okay, just want to make sure we don't crash, because we shouldn't crash at this point. So we've got we've got our atlas saved as variable tile sheet. So the next step is going to be to generate our quads. So we're going to have a variable called quads, and we're going to say that we're going to run our GenerateQuads function. And look at our LSP doing all this work for us. So our LSP knows that there is a GenerateQuads function, and it knows it takes in an atlas, a tile width, and a tile height. So we can go ahead and just do that, and we can say the atlas we're going to give is the atlas we just saved, which is our 9 pictures. Then the second is going to be our, how did we save our tile size constant? Did we save it? Let's save it with an underscore here between the words. We just want to be consistent so that we can follow things and not have bugs. So tile size and tile size, because we're lucking out, and it's actually just a 16 by 16 quad for all of these, and most of them are going to be that. So this is a good exercise, and then we can just replace it with our actual grass and sand and water tiles, all that good stuff. So we save into our quads variable GenerateQuads, which returns a sprite sheet, which is just a table full of different indexes of all the different X, Y, width, and height of a quad for an atlas. So now we're going to set, let's just set a variable here. We only have a 9x9 grid for this test. So for now, we'll just do a map width and a map height of 3 because we have only 9 sprites to chop up. So here's where we're going to actually assign our constants. And this is the part I'm most excited about, because if we look at our constants, we can have words like water or sand, you know, grass. And those words map to numbers, and those numbers map to quads. So we'll ultimately be able to just say, you know, here's a table of what this screen looks like. It's going to go top left grass, then top edge grass, then pavement, then pavement, then pavement. So we can kind of abstract away all of this junk and just be able to kind of visually draw out our maps. And once we get this working, it's going to be so much fun to just run around. And once we get our tile sets going, we can just map out a whole bunch of different levels, because it'll be rendering for us. So like, we just got to do this upfront work, and then hopefully it'll be easy for us. So what we're going to do now that we've got our map height, we want to insert the tile ID into each of these map locations. So what we're going to do is we're going to do another nested for loop. So we're going to index initialize starting at 1, because Lua is 1 indexed. So we can't, if we try to index into 0, we're going to crash. So we gotta have initialize at 1 there. And we're going to do for a same thing, a height amount of times do a column amount of things, right? So it's going to be, we're going to have this for X gets 1, comma, map width, do. And the first thing we want to do is, because we need to be able to modify something here in our columns. Yeah, in our columns. So we need to actually give ourselves a table to actually manipulate. So what we're going to do is we're going to table.insert, and this function takes in a table of which to insert something, and then a thing to insert. And in this case, we're just taking our empty tile sheet up here, and we're taking that sheet and we're just putting an empty table inside that table. So the table was empty, and now it's empty and full of empty. but we would be able to index at a tile 1 and see that it's an empty table. That it's a thing that can hold a lot of things, and it's just one of those things. So the table can hold a whole bunch of tables. So Lua is really just all tables like this, but let's continue on, and we're gonna be doing the interesting stuff here, which is table.insert, and we're gonna go into that empty table as of now, but we're gonna go into it at that first at the topmost row, and then we're going to actually insert into it a value. So it's going to be ID. So this is, we're going to be able to save our ID as whatever we want. So for now, let's just say, and you know what, we can maybe set it to be equal to, I want to say if we make it, let's just say we make it equal to 1 for now, just for illustrative purposes. And so for now, this will go through every width of every height and set that tile's index.id, because we're putting in this ID into the table at this index. So tiles at Y has a table with a value key pair of ID, and that's equal to 1. So hopefully, if we render this right, it should be just be all of our 1 sprites from our 9 circles sheet. So we're inserting the ID of 1 into there, and then all we have to do is render it. So I believe that's all we need in our init. Then we just need to render the thing, and what we'll do is we'll render it before Koboth so that Koboth appears on top. So I do want to turn off our grass rendering for now so that we can demonstrate the new rendering, right? So we should have, okay, util Lua 2 fails. We didn't pass in, we passed in tile sheets, which is not a drawable. Tile sheet is though. So now our grass is no longer there. So now we'll be able to see what our new rendering is going to do for us. So let's go ahead and add it right here. So again, a nested for loop, because we want to draw everything in our tile sheet here. So we're going to say Y gets 1 for map height, and this is the kind of pattern, right? We do everything, the height a number amount of times, a row, a column amount of times. So we're going to be doing the map width as well here. So here's where we do the tricky part, I guess, because it's like we save a variable called tile, like the individual tile, and we're setting that equal to the entire table at the index of whatever our loop is at. So we need this variable because we need to access its ID to be able to draw it. So when we go to draw, one of the parameters of love.graphics.draw, first you have to pass in the atlas, so it's our tile sheet, and then you have to pass in the quad. So we have our quads table that we did our GenerateQuad's function for, and we want to give it the index of our tile.id. So we have to save our tile into a variable here so that we can index its ID without it being a bunch of different brackets. So now that we're doing that quad's tile ID, then we have to do an X and a Y, and I think that's it. So our X, we gotta actually do X minus 1 times our tile size, because it's 1 indexed. So we have to do that because on the first one we want to render it at 0, 0, so we have to subtract 1, then multiply it by tile size to get the correct indices there. And then same thing for our y minus 1, and we times that by tile size. And then with any luck, we might be able to render, we're drawing all of our 9x9 pictures, but we assigned only the number 1 into our tile ID. So if we run the game, we only have 1. That's the first image. So this seems to be working, because if we go here and change this to ID 2, boom, we got all the 2s. So this is the kind of power of the quads like this. We're only loading 1 picture, but we can give it the appropriate quad index. And what's cool is, like, let's say 3, you know, and let's say we don't want to have to know what number it is. Let's say we want to go and say, you know what, I want to draw the 7th one, and we don't want to, like, this makes sense, 7th equals 7, that makes sense. But if we're drawing like sand, what index is sand? I don't know. We want to be able to just say sand and have it work. So if we're able to pass in the string constant there and have it be the correct one, which it is, that's super powerful. So we can do, and we don't even have to do, what's cool about the loop like this is we can go here and we can say, you know what, our width is actually 10. Our width is 10 and our height is 8. And now, why don't we go ahead and we want to render all the 9ths. So we say 9th there, and then boom, we got a whole, yeah, sand is 5. If you do the proof on that, you get sand is equal to 5. So check that out. We're only drawing one sprite, but we're able, you know, it's a 9x9 sprite. We're dialing into it, chopping it up into these quads so that we can give it a number and just render the whole thing. So the most, the last step of this, which I haven't figured out yet, I was able to get through this fairly accurate because I already did this today. So I had my little cheat sheet and I was on it. But what we want to do next, which I won't get to tonight, is we want to be able to give ourselves like a whole, because right now it's easy to make everything one thing, right? It's easy to make everything a 9th or everything a sand or water, but it's not easy to say, you know, we want sand, 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 pavement, 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 water, 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 sand, 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 and do that for everything. So we need, and yeah, so Fart Knocker, I'm gonna be adding collision detection for all the tiles. So like a grass tile will have a property that detects, or once it detects a collision with both, it'll render a grass in front of his feet, so it'll look 3D just like in Pokemon or in Link's Awakening. So that will be a feature in there. So we'll just have to we'll be adding collision detection for every tile basically, and that's going to be one of the side effects of one of the collisions. So I haven't quite figured out how we're going to do this, because right now it's easy to do this and say give every single tile ID this, but I want to get to the point where we can do something like this, where we say, and not quite like this, but let's say we render them all as 9s, right? And then we go in and say, you know what, the top left one is actually a 2. So we say tile at 1, 1, which is top left. Tile 1, 1, its ID is actually going to be the 2nd, or sand, or whatever we want. And check that out. We got 2 up in the top left. So this is like the basics of what we need to draw the whole map. So we need we need new sprites. First of all, we need like all the edges, all the corners, all the different types of things. We've got sand, we got dirt, we got grass, but we need pavement, we need corner pavement, we need edge pavement, we need flowers for the grass, we need all that stuff. So we've got the bare bones of starting to do this. The hard thing is trying to visualize. So like the rightmost one would be the 10th. It's the first row, but the 10th box. So this should be the top right. And let's say we just give it a third. So that should be the top right is third. Nice. So now we've got little billiard balls. But it's just so cool because now we're only doing the one picture. So we can have our own sprite sheet. We'll replace the 9-ball sprite sheet with all of our art that has everything, or you know, just environments instead of characters. But what's so cool is like under 1 megabyte of photo, and we could render every single iteration of every single image, all from that one image. I don't know. I think it's really cool because it's just the one picture there. So we'll have, you know, instead of these being standalone pics like this, they'll all be sandwiched up against one another, and then we assign them the correct numbers, and then we don't worry about the different drawables. We just say, I know the tile ID gets grass, that's 5, whatever it is. And then we'll be able to render all our fancy stuff. So I guess for now, let's just make our bottom left and bottom right billiards a different color just to kind of prove we can. And then maybe we call it a night. So that should be the bottom left. So we'll do this 4th. And then 10 should be the bottom right, and we'll put 5th here. So the hard thing, oops. I guess, hold on a sec. We crash indexing 10. I'm wondering if we, oh, it's because, yeah, our map height is only 8. So this should be 8. 8, 1, and then it should be 8, 10. Okay, so there we've got all the corners. So what I'm trying to figure out for tomorrow's episode is to have, I'm recording a macro again. What I'm trying to figure out is how can we model these tile IDs in such a way where we can almost visually draw the map. Because right now, it's not very apparent. It's not very apparent that that this is the top left corner and that this is the top right corner and bottom left and bottom right. Like we could do that. We could do that and we just meticulously map it out, and I don't want to do that. I want it to be more visual. Like I want it to be able to say, like if we know it's 10 across, that we would say grass, 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 and that we can say the next one beneath it is sand, sand, sand. So if this was a 9x9 or whatever it is, I want it to be something like this, where we can kind of visually script it in the sense that, hey, this is top left and that's grass. The one right next to it is also grass. The one right next to it is also grass. One beneath it is sand, sand, whatever. So I'm just not so sure how we assign it pretty like that, because in order to assign the tile ID, we have to index into our tiles table and we have to manually assign the ID. So it might be, we might literally have another table that holds a bunch of tile IDs. And this becomes one part of what we insert. So like this would be one, and then if we do it again, gosh, here, let's see. You know, we would have a massive another table, because we want to visually be able to see, and this would be, yeah, I don't know how to visualize this in a way that makes a lot of sense. But we really could just kind of we could assign them all like this visually, so that we can lay them out and see that the top left is this one, the one right above it. I don't know. I still got to work that out. But we've got the workings of what we really need to get things going. And I'm getting excited. Because what's so cool is we got the character, we're about to have sprites rendering how we like it, and as soon as we get the ability to just draw maps visually, and then we add multiple maps, then we can add the scene transition from left to right. We scoot it and you're at the new map, and once we have that functionality, our game could be 100 quadrants. You know, I mean, we have to make each quadrant, but our game could just be expanded by so much. So I'm really excited to get the scene transitions done once we get this stuff up and rolling in a way that makes sense, because it doesn't make sense to just assign it manually like this. I mean, it kind of makes sense, but it doesn't visually help you sculpt the level. So I want to be able to give the level. There's got to be a way to do it. There's got to be a way to do it. I'll think about it and I'll work on it tomorrow, because ideally it'd be super cool to just set a table, but it's a table not necessarily of values. Like let's say we had a 9x9 where we would say like this, you know, the code for all the things. What we could do that visually, doing something like this is so much more visually indicative of what we're trying to do versus these manual assignments. So if we could, and it might not be one, it might be sand and water or whatever it may be, but to have it, and see, I like the numbers because the numbers are like equidistant, so we can kind of see, you know, that this is the very top left, this is right beneath it, that's right to the right of it, and we can visually see the 8 numbers across, or 10 numbers across, 8 numbers down, and then we can draw like that. Storyboard each frame and document it with a unique number. Yeah, exactly. We can make a little cheat sheet so that we can draw it by number like that. And actually, Colton Ogden, which we should give him a little shout out in our notes here, because we're using his function GenerateQuads. Let's go do that real quick. We'll just say, thank you, Colton Ogden, because he wrote this function that we're using. But at the end of the day, it's super simple. You know, we just give it the value of which our quads are going to be, and we just assign a quad to be each one of those at the right X and Y position. And then we use it like that. So we gave him a little shout out. Now, I think I'm going to call it a night, because we've got all I wanted to do today, which was get our sprites rendering, and I can worry tomorrow about how to kind of visually tackle this. But Fartknocker, I think this is a cool, I like that idea like a storyboard, you call it. And there's a little Python function that Colton Ogden wrote for tile sheets that you run the Python function on your picture, and it'll paste a number, like a storyboard, like you're saying, like on which number is what sprite sheet, which will be super useful, because one tricky thing about this is if our sprite sheet grows, that'll change the number of index that we're trying to slice into with our GenerateQuads function. So water's no longer 3, so every hard-coded 3 is now something else if we change our sprite sheet in a certain way. So I want to try to figure out a way to minimize that. So that might be like we calculate the maximum number of sprites we think we'll need, and we make sure we build all of our first sprites in that top row, so that everything next will only be new numbers and it won't be overriding any of these other numbers. Because if we draw new stuff in a column beneath it, it's going to shift all those numbers, and we don't want to be digging around in that. So maybe I'll tally up. Let's give us some homework here in our notes, and we'll say, oh, look at this, we got this. Draw a whole screen using tile key codes. So the key codes are what I was calling the tile ID. So that number that we're drawing, that's the key codes I'm talking about. And then we'll give ourselves a to-do list of tally up all Link's Awakening overworld sheets. And that's just to get an idea. We're not going to do a one-for-one copy of every type of sprite there is in Link's Awakening, but that'll give us a good idea. Like if we have that much variety, then we'll be set. We'll just have to be smart about it. So tally up all Link's Awakening overworld sheets, and then I liked Fartknocker's word of storyboard for the numbers. Figure out Ogden's storyboard script. It's funny because storyboard and script are both like movie terms, but this is both programming stuff. Like the script is the Python script that Colton Ogden wrote, and then the storyboard will give us the numbers of all the pieces so that we can easily reference them when we're building the levels. So what else? There was another homework I wanted to do, and I guess it's just configure pretty way to draw or to declare tile IDs, hopefully in a grid fashion. Because if the storyboard doesn't work out, and at a glance, it'd be nice to see, because the storyboard will help us know what numbers we're trying to do. But if we look at a table of 80 numbers, which is what it's going to be, and we're like, okay, well we need to rotate the grass in the bottom middle-ish area, and then we just see numbers. So it would be nice if we could standardize a way, we have like a maximum character amount for our tile ID string values, and then we can kind of have a standardized 10 by 8 grid so that we can visually type out exactly like this. Pavement, dirt, whatever that is. So that's my homework for tomorrow. Hopefully I can figure that out before I stream. I think this format worked pretty well, where I kind of do my homework before stream and then come and show you guys what works. I think that makes for a pretty solid hour, and we're headed up right at an hour. So I think I'm gonna wrap it up. Let's go ahead and do our git commits here. So first we'll check our git diffs. We've got, we've got some white space there in our player class. Let's go ahead and fix that real quick. Yeah, look at all that white space. Okay. Now, we'll go... Where did our Tmux go, man? Were we not in Tmux that whole time? Oops. Were we really not in Tmux, or did I just exit out of it? So we moved from our main state. We moved all our dependencies into our dependencies file. We gave us some more constants for this, drawing our 9 circles. Then we did our quads drawing. So we have a table of tiles. We use our GenerateQuad's function on our tile sheet. We give it a map width and height. We assign an ID into each of those tile IDs, and then we're manually assigning ones. We shifted our window so that we can see Sekijo drinking that monkey booze, and we're rendering all of our quads. So it was a pretty solid day. We'll say git add and commit with a message saying we added GenerateQuads and assigning quads to tile IDs, which was a huge step today, so that's good. And then we'll get push. So if you're at home trying to use git like I am with git A and git P, it won't work because I've set these aliases here. So git add is actually git add everything and commit with a message. So I just do git A, put it in quotes, and I can commit with a message, and then git P pushes to my origin repo. So I've got the aliases there, so it won't work if you try to do it at home like that, but I highly recommend using git. I really love it. Anyways, thanks guys for watching the stream. If you guys, I've got a couple viewers. I like rating channels. If you guys are down enough to maybe say hi to somebody, let's see if we've got anybody willing to, or that is rateable. Just because it's a really cool thing and I think it's fun. So let's see if I can send you guys over. I don't got any raids available right now, but I guess we'll just call it a night. Thanks for watching, guys. I will be back tomorrow, and hopefully we can get some more stuff done. If you're watching and haven't followed yet, consider giving me a follow. We're trying to get to 20 so that we can get to 50 and get affiliate so that we can do some more cool custom graphics and stuff like that. So take care. Have a good night. Thanks for watching.